Okay, in this video we're going to talk about multiplying fractions. And the truth about multiplying fractions is we actually do it before we add and subtract because it's actually easier and you've already been doing it. Truth be told, you've already been doing it. When you were making equivalent fractions, you were multiplying. Okay? When you said, oh, I want to reduce a fraction, let's say we want to reduce 15/25. What did you do to reduce 15/25? Yeah, you divided them both by 5. Now, another way I saw one of your classmates write it is they wrote it like this: 5 times 3 over 5 times 5. And since you know that 5 over 5 is the same thing as 1 whole, those really canceled out, right? The 5 divided by 5 became 1, and then you were left with a reduced fraction of 3/5. So that's really the idea behind multiplying fractions in general, okay? If I have two fractions that I'm going to multiply, let's say I'm going to multiply 3/4 times 1/2. So actually we're taking half of 3/4. We could actually look back at our 3/4. Okay, right here would be 3/4, right? If you ignore the last fourth. If I was going to take half of that, it doesn't really, what is that? So I need another fraction. So half of 3/4, let's line it up. Here are the eighths. Half of 3/4 is how many eighths? You can see them, 3/8. And you're just multiplying across. 3 times 1 is 3. 4 times 2 is 8. So we made a new fraction. I just want you to be able to see that, how, oh, look, half, if I cut half of 3/4, I'm going to get 3/8. You see that? The picture of it? Okay? Now, what happens when the fractions get a little bit more complicated? Let's say I have 3/4 times 8 over 15. Well, I want to go back to that idea that you showed before of factoring, because just FYI, what is 8 divided by 4? Does anybody know the answer to 8 divided by 4? 2. Okay. What is 15 divided by 3? 5. What is 3 divided by 15? Oh, actually, that would be 1/5. Right? 15 divided by 3 is 5, but here I have, remember the denominator tells me how big the piece is, it's a size 15th. I only have 3 out of 15. So we reduce this down, 3 over 15, we reduce by dividing by 3 over 3. 3 goes into both. That's how we get the reduced fraction 1/5. I say all of this to come back to this idea of this fraction. Now I can multiply across, but remember, eventually I'm going to have to reduce my fraction, aren't I? If I multiply across. So if I multiply across, I would get what? Can 24/60 reduce? Okay, what would go into both 24 and 60? 2. Okay, we can start with 2. So this is us reducing now. If I divide them both by 2, I get half of 24 is 12. Yeah. Half of, okay, is 30, right? Half of 60 is 30. Can that still reduce? What else could it reduce down to? Because you divide it again by 2, right? 6/15. Could 6/15 still reduce? 2. This is divided by 3. This is divided by 3, right? Isn't that 2/5? Are you with me? 2/5? Okay. So that was a lot of multiplying and then divide, right? Essentially, this problem is the same thing. I'm going to just draw it down here as 3 times 8 over 4 times 15. Now, one thing to notice about the multiplication property is it's commutative. That means it doesn't matter the order in which I multiply, right? So what I want you to see is I could rewrite this as 3 times 8 over over 15 times 4. Now, do you see this division problem right here? 3 divided by 15 and 8 divided by 4. We already know that 8 divided by 4 is what? 2. That's the idea of cross cancel, okay? If you see within the fraction 3/4 times 8 over 15, if you see that they have common factors, you can actually reduce by cross cancel first. And that's what this looks like. 4 goes into 8, 4 goes into 4 once, 4 goes into 8 2 times. What number goes into 3 and 15 evenly? 3. 3 goes into 3 once, 3 goes into 15 5 times. Now we have 1 times 2 is 2, and 1 times 5 is 5. How many people liked doing this reducing, multiply big numbers across and then reducing it down? Notice that we got the same answer. I'm sorry that I put this all over the place. Let's try a different one. Okay? 3/5 is 2/5, yes. Okay, let me try a different one and we'll really demonstrate how this works, okay? So let's say we have 8/11ths, and you might notice these problems are on your page. 8/11ths times 33 over 40. Okay, again, we're going to try this cross cancel, because the cross cancel, I'm telling you, is a lot easier. Does anybody know off the top of their head 8 times 33? I don't know that. I don't know that. So I don't expect you would know that, right? It's really big. It's a really big number. So if we look across and I see 11 and 33, is there anything that can go into 11 and 33 evenly? 11, right? 11 goes in here once, 11 goes in here 3 times. That's the same idea as 33 divided by 11 is 3. That's the same thing. It's just you see those fractions, the numerator and the denominator across. What about 8 and 40? What number goes into 8 and 40? Yes. So 11 is the number. So you said 3 because you're thinking 3 doesn't go into 11, right? But so what you're getting is, I think where you're getting the 3 is that you're saying 3 times 11 over 11. You see what I'm saying? 33 is 3 times 11. But what we're canceling out is the 11, because 11 over 11 is, what's 11 divided by itself? Yes, that's called the greatest common factor. We're getting rid of the frequent number, which is the GCF. Now, what number? So actually, you had written it out like this before. You had written 8 over 40. You could write that out as 8 over, what's 40? 8 times 5. 8 times 5, right? So what we're canceling, because 8 over 8 is the same thing as 1, what we're canceling is the GCF of those two numbers. So since 8 goes into 8 one time, it becomes 1. 8 goes into 40 5 times, that's where we're getting the leftover 5, because what we're canceling is the common 8, the GCF. Okay, so now when we multiply across, what do we get? 1 times 3 is? 1 times 5 is? 5. So that fraction, when we cross cancel, it's so fun because that fraction becomes fully reduced. And then it's much easier to multiply smaller numbers, isn't it? Do you guys want to see one more example? Yeah. Right. Okay. Yeah. So let me try another one. I'll just take the next one from your sheet. 8 over 9 times 15 over 24. So when we cross cancel, we're looking for what is the biggest number that goes into both. When we look at 9 and 15, do you see that they have something in common? 3, right? 3 goes in here how many times? 3 times. 3 goes in here 5 times. Okay, now let's look across 8 and 24. What's the biggest number that can go into 8 and 24 evenly? 8. 8 goes in here once. 8 goes in here 3 times. Now we multiply across. 1 times 5 is 5. 3 times 3 is 9. Okay? Now, if you have mixed numbers and you're going to multiply them, you do have to change them first to improper fractions. Okay, so here's a problem. 4 and 1/2 times, I'm just going to do the first fraction. Actually I'll do this one, times 2 and 2/5. Okay, you can't just multiply 4 times 2 and then 1/2 times, you can't just do that. So you have an addition problem here. It would require actually much more work if you were going to leave it like this. So we're going to always change to improper to multiply, and divide. So who can tell me, how do we change that mixed number into an improper fraction? Yes, it would. So that would be 9 over 2, because you did 4 times 2 plus 1, over 2, times 12 over 5. And now we're always going to want to look and see, can we cross cancel anything so that we don't have to multiply such big numbers in order to divide them out. It just saves us time. So do you see, can 9 and 5 cross cancel? No, 5 doesn't go into 9 and 5 is prime. Could 2 and 12 cross cancel? What would that cross cancel down to? 1 and 6. Does everybody see how she got the 1 and the 6? 2 goes into 2 once. 2 goes into 12 6 times. So we're just dividing them. It's just like if I had the fraction 12 over 2 would equal 6 over 1. It's just reducing that fraction. Okay, now when we multiply across, 9 times 6 is 54. 1 times 5 is? And can I change that? How do I change that back into a mixed number? Yeah, 5 into 54. 5 goes into 5 one time. 5 goes into 4 0 times. What's our remainder? 4/5. So that's going to be 54/5 is equivalent to 10 and 4/5. Any questions about that? And then we have a few word problems. And what I would suggest with the word problems is I would suggest reading them twice and then trying out some different things. Now, these are all going to involve multiplication, so that's a clue about them too. Let me just read one of the word problems. Let's just do one of the word problems together, and then we can always come back to this if we still have questions. So I'm just going to go on to the activity, and we'll see this one. Number 2, solve the application, show your work. Answer all questions in complete sentences. If Mark drinks 2/3 of a quart of milk each day, how much milk will he drink in 6 days? So what would we do there? Yeah, 2 over 3 times 6. Now, if I don't have, the 6 is a whole number. How can I make it into a fraction? Over 1. All fractions are always being divided by 1, because what's 6 divided by 1? 6, so it's equivalent, right? So all fractions all whole numbers, can be made into fractions by putting them over 1. When you go outside in the sun, you're a whole number. You yourself, you're 1. You go outside, you look down on the ground, and you see your shadow. That's your denominator of 1. It's invisible, right? Just like the 6. The 6 has a denominator of 1. Did it? Okay, what can I do? What can we do to show? What would we do now to multiply? Okay, should we cross cancel? And this becomes 2. And now we have 2 times 2 is 4. 1 times 1 is 1. 4 over 1 is 4. What would be the sentence answer? Who could come up with a complete sentence to answer the question? Mark drinks. Oh, you said 1 gallon because it's 4 quarts, which is the same thing as 1 gallon every 6 days. Okay, we got 4 quarts, but she just converted it to gallons, so not to be confused. I was like, where are you getting 1 from? Oh, she did some unit conversions. Okay, try the rest of those problems.